All right, so we're on 1A.4. This is part one. Polynomial function and the rate of change. We started off by reviewing parts of the polynomial. What is a polynomial function, right? A polynomial function is monomials or the sum of the monomials, right? Sum meaning that your terms are being added or subtracted. And the key thing about a polynomial is that you can't have a variable as a power, a variable in the denominator, or a variable underneath a radical. Does that make sense? Okay. So when we talked about polynomials, we talked about the degree is your highest power of your polynomial function, and then the leading coefficient is the constant that's with that highest power, right? That factor with the highest power. Okay, yeah. Turning points. Your turning points are where you are increasing, then decreasing, or decreasing, then increasing. And your end behaviors, we talked about, remember the little stick man with our dance? Our dance is if I'm odd, I'm going to have opposite behaviors, right? If I'm even, we're going to have even behaviors. So, yeah. What else did we do? Yes. So then we talked about relative maximum and relative minimum, okay? When you're using the word relative, that means that your end behavior is either going on forever to positive infinity or negative infinity on the y-axis, right? So I can't say it's my absolute because the value is going on to infinity, right? So when we look here, there is a absolute maximum because I'm not going higher than these 2 points. Does that make sense? But there is a relative minimum, and that's because at this point, this is a minimum because I decreased and increased, but it's not my absolute because it goes forever to negative infinity, right? Okay, there's that. Then we talked about, went through just identifying the intervals according to Khan Academy. How I've learned and how I've taught writing intervals is correct. Use parentheses because you're not saying it's equal at some point. You're just saying when it happens. And we're saying that I am increasing from negative infinity to -1. So parentheses is utilized. Okay. And that's why we wrote it in parentheses. When you are labeling or identifying your maximum or minimum, your extrema, you are asking where X marks the spot. Where it is, X marks the spot. Does that make sense? What it is your Y. Where is your X? What is your Y? Okay. Where am I going on there? Well, I'm going to X equal blah, blah, blah. What is it when I get there? It's 6. So when it's asked you to locate or what is your extrema, you're going to say my max is 6 at X equals -1. That's how I got there. Or my min is -6 at X equals -2. That's how I got there. Okay. And I feel like this is where we stopped at. This is where we stopped at? Okay. If you weren't here, does that brief, I can't talk anymore. Does that brief make you feel caught up? Okay. All right. Here we are. We're all here? Yeah. All right. We're going to talk about calculator usage today. So we have our graphing calculator that you should have access to. We're going to use the calculator to talk about finding the intervals of where the function is increasing or decreasing, aka our maximums and our minimums have to be identified in order to do that. And we're going to use this function. So we have the quadratic function, not quadratic, the quintic function. And why is it quintic? 5. My highest power is 5. So we have a positive 5th degree polynomial. We're going to write that. We have a positive 5th degree polynomial. Okay. Now, it's a positive 5th degree polynomial, but to be more specific, it's a trinomial. And why is it a trinomial? Because there's only 3 terms, right? So it's a positive 5th degree trinomial, if I had to describe it in its full of what it is. Exactly. Oh, it's a negative. Because Ms. Jones is tripping and not looking at her notes in front of her. You know, the paper right here that says, "Oh, Jones, make sure you say this." All right. So we're going to also write some things, practice some things. We're going to practice changing our mode of our calculator. The reason why we're going to do that is because most of the times for the AP testing, you're going to round to 3 decimal places. And if you're not strong at decimal place and there's a rounding to decimal places and you're allowed to use your calculator, why not make that part of your calculator feature, right? So we're gonna reset. Once we reset our calculators, we're gonna go to mode, and we're gonna switch from float to 3. Okay, and then we're gonna go ahead and graph. Cool. All right, so I'm gonna grab my handy dandy Sylvie, the calculadora. You heard me. I'm going to reset her. 2nd plus 7, 1, 2. I'm going to go ahead and go to mode. And I'm going to switch from float to 3. Okay. Oh, float. My bad. Okay. So now we're going to go ahead and graph. How do I graph? Press what? Y equals. I go to Y equals, and I'm going to type in what I'm graphing. So we are graphing that right there, negative 2x to the 5th, arrow, plus 10x squared, plus, I don't know what Pandora wants. I really don't know. The whole song back and forth. Calm it down. Okay. All right. So now I have it. Now I'm going to hit graph. And it's going to do some thinking. My think's a little longer than yours. And I said it thinks a little longer than yours. She's thinking. Okay. Don't judge Sylvie. So hi, Sylvie. All right. So when you look here, can I see my full polynomial? I cannot. So I'm going to, I either can zoom out or I can adjust my window, whichever way you want to do it. If I go zoom and I zoom out, I'm going to hit zoom, zoom out. And Sylvie's thinking. She's thinking. How many zoom outs did you do? I just did 1. I don't like how Sylvie zoomed out. I feel like she did the most. I don't know what y'all did. I'm going to do zoom fit and see what happens. Now, remember, my calculator is a little older than y'all's. Sylvie does her own thing. You know, if you do zoom fit, this is what it automatically does. Zoom fit. That's because you're changing how you view the calculator. It's the same graph. It's just very zoomed in and your intervals are different. So I'm going to go back to reset to show you when it starts looking funny, like, ooh, I don't like that. That's why sometimes it's just better to just change your window settings. To go to window. And I know that my maximum needs to be a little higher, so I'm going to change my maximum to 20. Hit graph. By changing my max on my X, I changed the wrong maximum. I'm going to change my Y. Yeah. I just put 20 because you're zoomed in. You can reset, go to zoom and reset your calculator, guys. Yeah, now it's at the top. So I'm going to do 100. Let's see what happens. I'm going to go to 100. She's thinking. She's thinking. Oh, look at Sylvie. I see my max and my min. Wait, look at mine is doing. Yeah, mine. Change it. Is it showing the wrong graph still? No, it's not the wrong graph, guys. You're seeing a different view of the graph. I was like way zoomed out and it was still showing. So here we go. Hit zoom. You see where it says standard? That's just going to take you back to square one. Zoom 6. If it takes you back to square one on zoom 6.
Yeah, it's not my calculator. Really right graph. It was. I tried to do standard and like all the things. What did I say? It did you like? Oh, here, maybe it's because I have to. Yeah, there was this one.
Yeah. You know that everything. Yeah. I think not.
I don't know.
You did.
I didn't read it.
All right, so I went back to where it's at. So this is in standard view. And I know that I cannot see. I can go to Windows. My Y is my problem, right? So I can't see my Y. I'm going to try 50. If you don't want all those bunch of X's, that's your Y scale. I can say, okay, I'm going to count by tens. I'm going to count by whatever, but I can change it and it won't be like all those stacked up things, okay? So now, oh, look how perfect it was just for me fixing 50 and changing my Y scale to 10. Okay. You have to be patient with a calculator. Okay. It's a calculator, but you're still the person controlling the calculator. It is not going to spit out everything that you may need. You need to know what you're putting in and what it means. If you don't understand what scale means, if you don't understand what your Y max and your X max mean, that's part of the math knowledge. Okay. So that goes along with the territory of learning the math and understanding the math. Okay. All right. So now here we go. We're going to find our relative max. In order to find our relative max, we're going to press second trace. So to find our relative max, we're pressing second, and then we're pressing trace. And we're going to go to maximum. So second trace. Do you see where it says maximum?
Yeah.
Second trace maximum. Okay. Once I'm there, you're going to go close to the maximum. You start from the left of it, and then you're going to go to the right. So you see how it says left? When I'm to the left of the max, I'm going to press enter. And it's going to tell you to go to the right of the maximum. I'm going to go over my maximum and go to its right. It doesn't matter how far left and how far right you are, as long as you go left and then to the right, press enter. And it's like, are you sure you want me to guess what the maximum is for you? And you're like, yes, why else would I have done all of this? So then you're going to press enter again. And it tells you, here's your maximum. I got 1.458. Okay, so we're second trace. And we went to 4. It says to go left bound. So I'm going to go left of the maximum and press enter. Then it says go right bound. And I'm going to go right of my maximum and press enter. And it's like, you want me to guess? Yeah, bro. And you're going to hit enter. It's going to think about it. And it says, here is your maximum. Okay, so my relative max is 31 and 409 thousandths at X equals 1 and 458 thousandths.
So you don't put the point, you don't put like X, Y.
Nope. Yes. Yep. All right. Now this time we're gonna do. Hey, you two. Do y'all need to be separated?
No, ma'am.
Let's stop it. Okay. Now we're gonna do the same thing, but this time we're looking for the minimum. So we're gonna go second trace. Yes. Then you need to move it. Just move your cursor till you get to it. So pay attention to the number as it's moving. So pay attention to it. Okay, I will have to come. That's a specific calculator thing, and I can come to it in a second. Nope. You don't need to clear anything. So you're gonna go to the minimum. This time you're gonna go near your minimum. So I'm gonna move my cursor to my minimum. I'm gonna go left. It literally tells you to go left. So I'm gonna go to the left of the minimum, press enter. Then I'm gonna go to the right of the minimum and press enter. And it's like, you want me to guess? I'm like, yes. And it's gonna tell me, what is my minimum? So my minimum is -5 and 966 thousandths at x equals negative 0.688.
Oh, wait.
Now that you have your maximum and minimum, can you write my intervals of increase and decrease?
Yeah.
Okay, that's what you're gonna be doing, and I will come around and help people. So while I'm helping, all right. So our increase. So we look at our graph. Our increase is happening from our min to our max. Do we see that?
Yeah.
We all agree.
Yeah.
So our increase is from negative 688 thousandths to positive 458 thousandths. I can't even talk. I don't know what I was saying. I don't know what I was saying. You know I was getting it. Okay. And then my decrease, remember you're defining your x. So if I'm going forever to the left, that is negative infinity, right? Negative infinity. Wake up, Sylvie. Wake up. Negative infinity up until my minimum. Agree? And that is at negative 688 thousandths.
Oh yeah, man.
And then my other decrease happens from my maximum. And if I went forever to the right for my x's, that's positive infinity. So my other decrease, I can't talk, is 1 and 458 thousandths to infinity.
Oh yeah.
Okay. That is how your intervals should look for increasing and decreasing using the calculator. Okay. Our connection is your extrema, our turning points. So where your max and mins, those are called extremas. Our turning points. And a turning point is where change occurs. Okay, so that's the conclusion, is that if there's a max and min, that means there's a change in my direction of my graph. Does that make sense?
Yes.
So the one
It's still on page
are the maximum.
Mhm. All right, so you guys are going to do example 3 at your tables. The connection. I wrote it. No, it means like what's connection, like connecting the thoughts of extremas and increasing and decreasing. Yeah. No, I didn't draw my graph because my calculator is up here, but if you need a sketch to remember, there it is. All right, here you go. Next, we're going to talk about using the calculator to find our real zeros, but I gave you your graph for this one.
Yeah.
So it's okay if I don't, I'm going to show you on the calculator how to find the zero, but this is a pretty easy graph and I gave you your graph, okay? So on the calculator, we're going to graph this and then talk about finding zeros on the graph. So we have 15 hundredths x to the 4th minus 1500 x to the 3rd minus 1 and 8 x squared. Now this is useful if you didn't have a graph and it wasn't as easy. Clearly we can see our zeros, right? On our graph next door, right? We can see our zeros. Zeros are just your what? What are your real zeros? You're looking for your x-intercepts, right? So if it asks for your real zeros, you're looking for your x-intercepts, okay? Now, when they say real zeros, that means that you write them as x equals blah, 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 blah. If it's an intercept, it's an ordered pair. If it says zeros, it's just a value of the x. Does that make sense? All right, so when I go to graph, I need to change. Anytime you want your graph to stop thinking, you just press the on button and it allows you to change whatever it's doing and make it stop thinking. So I'm going to press zoom. I'm going to go back to my standard window.
You think that's it intercepted right there? Or the 0, 0?
Yeah.
It looks like it's like right underneath.
It's touching it. It's kissing it. Kissing 0, 0.
Oh yeah.
All right. Okay, so we're going to talk about finding the zeros. It's very easy in the calculator. In order to do it in the calculator again, we're going to press second trace. So we're doing second trace, but this time we're going to, anyone want to take a guess?
Zeros.
0. You're so smart.
Oh, no.
Second trace, and you see where it says 0. Ta-da! You're gonna find your 0. Okay, so I'm gonna press 2. And you're gonna start from the left of the graph and work your way across it. So I'm gonna go as left. In order to find a 0, there must be a change in your y value, right? Your y values must change from negative to positive. Otherwise, you're not gonna find that 0. Does that make sense? Okay. So here, I'm going to press enter. And as I go right bound, which means I'm going to change my y from a positive to a negative. Doesn't matter how far or close. It's going to guess. And it says that your 0's at x equal what? Negative 3.
Max is like 1 on the left and 1 on the right.
Yep.
Why don't we just go to table and see where it?
Because what if it was a decimal? Would you ever see it on the table? Put it. There's no hovering. All right, so second trace, I'm gonna do it again. I'm gonna travel to my next point, working from the left of the graph. I'm left of it, I'm gonna hit enter. I'm gonna go to the right of it and hit enter. And it's like, you want me to guess? I'm like, yes, please. And it's gonna think. Sylvie's thinking a long time. Sylvie, you're embarrassing us right now. And what happens? Oh my gosh, why did Sylvie tell me she can't find a 0 there? There was no sign change in my y. Okay?
Oh, that's what it's called.
Because it's constant right there. But there's no sign change in my y. And because there's no sign change in my y, I know that this intercept is a turning point. It's a max or a min. Does that make sense? Yes, because it's 0, 0. Yes.
Wait, so every time it does that, we just know that it's x equals 0?
That every time it does that, it lets you know that there is no change, that is a maximum or minimum value.
That's
Good.
good.
This is a relative maximum. This is
because the other ones are in
this is a relative maximum. I increased, then I decreased. Okay. So x equals 0. So by knowing this, if I did 4 at that point, would 4 work? Yeah. If I went to the left and I went to the right and I hit enter, it's going to say your maximum is at 0, 0. Okay. Because your maximum and your minimum isn't defined by whether your y's are changing. Okay. Your x-intercepts are. Whether it's going from negative to positive or positive to negative. All right. But we know x equals 0 is clearly a 0. Now we're going to do the same thing on the last one. Second trace, 2. I'm going to go to the left of it. All right, the left. So in order for there to be a 0, I have to go from a negative y to a positive y. Agreed? I'm currently negative. Hit enter. As I go to the right, did it turn into a positive? Yes. So that means there's a 0 in between these two values. Hit enter, and it's at x equals 4. Okay. So that's how you find the 0s. I was gonna leave it up to you. Oh man, I was gonna leave it up to you to do I still can leave it up to you to find your maximum and your minimum. Using there, and then yeah. Huh?